Hello, today we are going to learn about the maxima and minima, which is just a fancy way of saying the maximum and minimum. It's actually just the plural, not fancy. But anyway, so that's what's cool about quadratics, unlike linear equations, is that they have a maxima or minima. So a highest point or a lowest point, which is also called the vertex. So this tells us, the most profit we can make or the least cost we can incur, the highest the rocket flies, things like that. So anytime you see most, least, best in a question, you know that you're trying to find the vertex. So how do we find the vertex in a quadratic relation? Well, it depends on the form that we're given. So if you want to pause the video and fill this out so then you can just listen to me, you can do that. There's three different forms we could be given a quadratic in: vertex form, factored form, or standard form. Okay, notice that the A is different. The A is the same in all three forms, but the other numbers are all different. And that's because each one tells us different information about the parabola. So vertex form is the simplest one to see the vertex because it's just the h and the k. H is the x value of the vertex, k is the y value. Donezo. In factored form, we can find the zeros. Then the x value of the vertex is the midpoint of the two zeros, and then you can take that x value, put it back into the equation, and bam, you get your y value. But it's standard form that we're going to learn how to find the vertex from it today. So we're going to learn two new methods. One is called completing the square, and one is that the x value of the vertex is negative b over 2a, and we'll talk about that. Okay, so it's really just important that you understand every single quadratic has a vertex. That's one of its features. So no matter what form it's in, we need to be able to find it. So the first method is called completing the square. So you'll notice that I have it actually done for you. So you have a couple choices. Either you can pause the video and just copy this out and then listen to the explanation, or you can write it as you go. That's kind of your choice and how you learn best. So let's take a look at what is going on here, though. Here is a quadratic. It's in standard form. We cannot factor it. There's nothing else we can do, so we need another method to find the vertex. So what we're basically doing, look at the end result. We're trying to get it into factored form. So factored form always has an a value, which is the same, and then it has a perfect square. And then it has some number out here. So the thing here that we need to realize is that in order to get it into vertex form, we need to create a perfect square trinomial that we can then factor to become a perfect square. So what we're doing is a little bit of mathematical manipulation in order to create a perfect square, which you can see is right here, so that it can be factored as a perfect square, and then it can be in vertex form. So that is the purpose of completing the square. We want to create a perfect square trinomial. So the very first thing we do is we remove the a value, but only from the first two terms, okay? We only take it out from the first two terms, and we leave c just chilling like a villain there, okay? So we need now to create a perfect square trinomial, which means we need a constant here that will use this guy and this guy as the a and the b in the perfect square trinomial. So think about it. 6 is 2ab, right, in a perfect square trinomial. So if we divide both sides by 2, you get 3 as ab. But we know that a is 1, since there's nothing in front of it there. So we know that b is 3. So then we square b to get 9. So what you do basically is you take half of this number and square it, and that is a number that makes the perfect square trinomial. That's how you do it, because your a is always 1. So you just take half this number and square it. So you put the 9 there. Well, there's a problem though. We can't just add 9 into an equation wherever we want. It changes what the parabola would look like. That's not what we're trying to do. We're just trying to change the form, not the actual quadratic. We need that to stay the same. So because we add 9, we subtract 9. This gives a net sum of 0. So you're not really actually changing anything. You're just changing the way the equation looks. So now you want just this perfect square trinomial in the brackets. So you have to actually remove this 9. This negative 9, she has to get out of there. So you want to get her out of the bracket, which means that you have to multiply her by 2 first. So that's where we got minus 18, because we took 2 times minus 9 and we left her out. So from there, we just collected like terms here. Negative 18 plus 3 is negative 15. And inside here, we just factored this as a perfect square trinomial, which is x plus 3 all squared. So this is the vertex form of this standard form equation. And so we can see that the vertex is negative 3, negative 15. So this is a tedious process. You might have been listening to that and be like, she's crazy. I do not know what is going on. So the good news is I'm not actually going to require you to have to complete the square on the test. I'm going to teach you a different way, but we're going to use completing the square in order to learn why we're allowed to use this much simpler method, okay? So what I'm going to do is I'm going to complete the square on just the general ax squared plus bx plus c and show you what the x value of the vertex is as a general rule. So just before I do that, I'm just going to give you one more example of completing the square just so you really get what's going on. So what if we did 3x squared, I don't know, minus 12x plus, 10. Okay, so the first step is to remove the common factor from just the first 2 terms, not the third. So you take, or you actually, you remove the a value no matter what it is. So I take out 3 and I'm left with x squared minus 4x and then plus 10. All right, so then I leave this 3 chilling out here. I want to make a perfect square trinomial. So I have 4, which gives me 2, and then I square it, which gives me 4. So I get x squared minus 4x plus 4 minus 4. I have to add and subtract in order to not change the formula. Now I want this negative 4 out of there, so I have this beautiful perfect square trinomial. But because she's in the bracket, she has to be distributed. She has to be multiplied by 3 before she can just leave. All right, so now I collect like terms on the end and I factor this perfect square trinomial. So I get 3 bracket x minus, 2 all squared and minus 2. So my vertex is 2, negative 2. All right, so we're going to do that here with just the general form so we can come up with a general formula. Now, this is advanced. I'm not going to pretend that this is something easy, but for those of you who are, you're going on to functions next year, you might be taking math in university, getting used to proofs is going to be a very valuable skill for you. So, first thing we do, we remove the a value from the first 2 terms. So remember that common factoring is just another way of saying dividing. So when we take ax squared and we divide it by a, we just get our x squared. But what happens when you get bx divided by a? Well, you get b over a, and there should still be an x there. And then the c just remains. So now we take half of this b over a and square it. So half of b over a is b over 2a, because if you have b over a and you take half of it, which is the same as just multiplying by a half, you get b over 2a. Okay, and then you got to square that. So b over 2a all squared. You square the top to get b squared, and you square the bottom to get 4a squared. So that's what we're adding and then subtracting okay, in order to get that perfect square trinomial. Now we need to remove the subtraction out, but it gets multiplied by a first. So when you multiply minus b squared over 4a squared times a, what happens is that this a crosses off with the squared. So you're just left with minus b squared over 4a on the outside. And now this factors as a perfect square trinomial to the square root of this, which is x, the square root of this, which is b over 2a, and then this symbol, which is x. So the general vertex is negative b over 2a is the x value. Because remember, it's normally plus here, so we have to do the opposite sign. And then the c value would be this minus b squared over 4a plus c. That is the vertex of any quadratic in standard form where we are given a, b, and c in that order. So this means that the x value of the vertex is negative b over 2a. Now the y value is this gross nasty thing, but instead of memorizing that part, we just take whatever minus b over 2a is and put it back into the formula, run it through, and get out our y. It's a much simpler process than actually memorizing this y value. Okay, so let's look at some examples. Okay, find the vertex of the following quadratic and identify each as a max or a min. Okay. So again, our x value of our vertex is negative b divided by 2a. So our a is 2, right? It's this value here. And our b is 12. It's this value here. So we take negative 12 divided by 2a, so 2 times 2. So negative 12 divided by 4 is negative 3. So the x value of our vertex is negative 3. Then to find our y value, we take the negative 3 and put it back into the formula. So this becomes 2 times 9, which is positive 18, minus 36, plus 11, which is negative 7, I believe. So there you go. Let's do it over here. So the x value of our vertex is negative b divided by 2a. Well, in this case, the b value is negative 5. So we have negative 5 divided by 2 times 1. So that is just 5 over 2 is the value of the vertex. Sorry, the x value. To find the y value, we take that and we put it back through the formula. Okay, so then this becomes 25 over 4 minus 25 over 2 plus 13. Okay, and so if you use your calculator to do this, you can get out the answer. I don't have my normal calculator here, and I don't have the answer in front of me. You get 6.75. So either use both decimals or both fractions. So in this case, you could say it is 2.5, 6.75. Oh, and for this is a min because this parabola opens up. And this one is also a min because this parabola opens up. So now let's do this one. I'll do a different color so you can differentiate here. So the x value of the vertex is negative b, so negative 12 divided by 2a, so 2 times negative 3. So negative 12 divided by negative 6 is positive 2. So the y value is negative 3 times 2 all squared plus 12 times 2 minus 13. So this is negative 12 plus 24 minus 13, which is negative 1. So 2, negative 1 is a max because it opens down. So now we know how to find the vertex in any of the three forms, which is very useful in problem solving. So for example, we have the path of a ball is modeled by this equation. Notice that it's in standard form, okay? X is how far you are from a fence, and Y is how high you are above the ground. So what is the maximum height of the ball, and at what horizontal distance does it occur? So the maximum height occurs at the Y value of the vertex. So we first need the X value of the vertex, and then we use it to find the Y value. So remember, our X is just negative B over 2A. And when we use the numbers given, you get that the X value of the vertex is 1. You then take that 1 and you put it back into the equation to find your Y, which we find to be 4. So the maximum height of the ball is 4. That's the Y value. And it occurs after a horizontal distance of 1 meter from the fence. That's our X value. The second part says to sketch a graph to represent the path of the ball. Well, we already know the vertex, but we do want to find the y-intercept and its symmetrical partner. And then the zeros will also help us create a nice rounded out graph here. So notice that we can put x equals 0 into the equation to find that 0, 3 is the y-intercept. And we know the axis of symmetry occurs at 1, so its symmetrical partner is 2, 3. If you forget how to do this, you can go back to previous videos. So we're going to learn tomorrow how we can find the x-intercepts, but for now, we can put the equation into vertex form and solve for 0. Okay, so we know that the vertex is 1, 4. Okay, so we know that this is the vertex. And we know that our a value is -1 from standard form. So we can just write our vertex form. It's pretty handy. So from there, we're just moving everything over. You move the 4 over to get -4. You divide by -1, and then you take the positive or negative square root to get your 2 answers. So from this, you can create a really good graph, okay? So obviously it's much better labeled and drawn, but you get -1. And so there's a 0, and there's a 0. Okay, we have our x-intercept here, or y-intercept here, and our vertex here, and the symmetrical partner here. So there is our ball. We can put dotted lines here if you want to. You can put dotted lines, but actually you don't need those at all. The only time where it exists is that solid line. Okay, example 4, this is our last example. A football is kicked at an angle of 30 degrees to the ground at an initial speed of 20 meters per second from a height of 1 meter. 2 quadratic relations can be used to model the height in meters above the ground. One is with respect to time, and one is with respect to horizontal distance. So I want to make sure you understand that these both represent the same situation, but they're different quadratics because they are based on different independent variables. So one is how high it is in respect to the time that's passed, and the second one is how high it is with respect to how far it is from the start. So what should be the same in both models? Well, the maximum height. They both have dependent variable as height that's both the same. So the actual maximum height should be the same. But what's different will be the independent variable, because one will be the time at which that maximum height occurs, and the other one will be at what distance, horizontal distance, that maximum height occurs. So if you actually find the vertex in both equations, you should find that even though their t value and the x value were different, when you put them through, you should get the same h value. So I challenge you to do that. And then you'll be able to answer part C, no problem. So I set up the -b over 2a for you. So I'd like you to finish those, find the t and the x value, and then use those values to put back into the appropriate equation to show that it is the same maximum height in both equations. So guys, you learned how to find the x value of a vertex and the y value when you're given standard form. Again, this will be extremely helpful for you in your problem solving. Thanks for watching. I hope you learned lots.